This is topic 14, intermediate value theorem. So this is a very easy to understand theorem if you just look at the picture, right? So the intermediate value theorem, it says that f of x is continuous over this closed interval, and k is a number in between f of a and f of b. Then there is at least one number c in ab such that f of c is equal to k. So that sounds like a mouthful, right? But what that's saying is that if you have this closed interval right here, so if you have, you know what, let me actually draw you a picture. Let's see if I can find a blank piece of paper. So let me show you something that might be easier to understand, right, instead of that graph. So all that's saying is if you have, let's call this A and we're going to call this B. Alright, so you have f of A. So you have a point here. We're going to say that f of B is over here. Okay. So basically what we're saying here is if we have a, right, an f of B would be like somewhere over here. Alright, so that would be point f of, this would be B, f of B point right here. So all that's saying is if you have a function, a continuous function, let's make this a continuous function. Remember, a continuous function is obviously something that's no breaks, no holes or anything. All that's saying is that there exists, or there's at least one number, alright, so we're going to call this k here, to where that actually corresponds to a certain c. So all that's saying is if you go on this continuous function right here, from left to right, all the way through, if you go through every value on here, there's at least one y value that corresponds to one c value. Obviously, there could be more than that. Like, for example, if you have something like a parabola, you can have that cross. Now, on this one, that's saying the same thing here. Okay, so this is f of a, this is f of b over here, and this is continuous. All right, so this is continuous. And they're saying that that point k right here, k, they didn't do such a good job here, but k is this y value here. Alright, so k is more like right here. K is this y value here, and all that's saying is that there is some c value, some x values between a and b. So again, this would be a, and this would be b right here. This would be b, this would be a. Alright, so there exists some x values for this one, that one, and that one. Okay, so that's all that's saying. Now, let's run through a few examples. The homework is actually not too bad. It's kind of wordy, but it's not too bad, all right? So in this one, it says if f of x is continuous over the interval ab between f of a and f of b, then there's a sign change, and that's important because it's part of our homework, all right? So there's a sign change, then a root of f of x exists, all right? So I'm going to show you what that means. So what that means for this one, example 1, they're asking us to show algebraically that there's a root of the equation, all right? So if there's a root in the equation, what that means is that if I plug in one of the values, or I'm going to plug in the endpoints basically here, I have f of 1, and if I were to plug that in for x, alright, so the notice that that's going to give me a negative 1. And if I plug in the other endpoint, f of 2, and I have 4, 2 to the third power, okay? So that's that. So what that means is that if f of x is continuous, and notice this is just a cubic function, so it is continuous, all right, between 1 and 2. And they're asking you if there's a sign change, meaning if this is, in this case, this is negative and that's positive. If that happens, then because f of 1 is negative and f of 2 is positive, all right? It doesn't matter what the number is, as long as you have a sign change. Then there is a root. And remember, we already know that this is continuous, right? So there is a root between 1 and 2. Okay, so I hope that makes sense. So if I were to draw you a picture, even though this is not going to be exactly what this is, but basically that's saying that between 1 and 2, so let's call this 1 and let's call this 2. So I'm not looking at my graph yet, so I don't know what this looks like exactly, but I do know that I do have a -1 and I have a positive 12. So what that means, if I'm only looking between those two, all right, and again this would be 1 comma -1, and this would be, let's see, 2 comma 12. Right, so what that means, well, how can I get from that point to that point? Where the only way that I can get through that point is by going through the x-axis. So there's your root right there. Okay, so again, if you have a if you have a negative and a positive y what do you call it, y component, I guess, then there must be a root because you must cross through it, assuming that this is continuous, which in this case it is because that's a cubic. All right. Now the next one, example 2, says find the value of c such that f of c is 25. So that's actually very simple again. All you're doing is setting this equation right here equal to 25. All right, and on that one, I'm not going to tell you use your calculator if you like. Use your calculator. And find the intersection and put this as y1 would be this. Y2 would be this. And then when you find the intersection, so again, find the intersection. You find that that c value has to be equal to 2.378. Again, so that's what it will look like in your calculator. Your calculator will look something like this. Like that, and then you have, this would be y is equal to 25 here. So that would be that line. So that's what that would look like. 2.378 and comma 25. Alright, so that's all you're doing on that. Alright, so let's look at our problem, right? So it's relatively simple. There's really not a whole lot of calculus anything here. You could do it all with algebra. But let's go ahead and turn this around and see a problem that's interesting. That could be hard to solve. Right? If you're looking at this, why don't you take a couple of minutes, alright? Put this video on pause and take a couple of minutes to see if you can solve this on your own. Alright, it's multiple choice, so alright, pause it now and see if you can solve it. Now, assuming you already have tried this for a couple of minutes, this is how you would do this, right? So notice that again it says, this is very important, if f is continuous on the closed interval between 0 and 2 and has values that are given in the table above, alright? So I have, notice that right here are my intervals, alright? So I have this and I have this. Alright, it says the equation f of x is equal to 1/2 must have at least 2 solutions. Alright, so must have at least 2 solutions in the interval between 0 and 2. Alright, if k is equal to what? So this one, it's actually kind of difficult if you can't picture it, right? So what I like to do sometimes when there's nothing else I can think of, so I like to at least give me a graph, right? So if I graph this, and let's say that this is 1 and this is 2. Alright, so let's say that this is 1 and this is 2 over here. Alright, notice that I have one point at, let's see, 0, 1, right? So 0, 1 would be right here. And I have another point at 2, 2, which is right here. Now it's telling me right here that f of x is equal to 1/2. This equation right here, remember this would be like f of c is equal to 1/2, right? So it says right there that, and I'm going to write it right here, so this would be f of x is equal to 1/2. So about halfway through, right? This line right here, there's 2 solutions. Alright, at least 2 solutions. So what that means is that k has to be, well, in order for you to do that, you kind of have to go through here. And notice that I have choices here, right? So basically what you're trying to do, you have to cross this line. You have to cross this line. Now because of that, look at your choices. Can it be 1/2? Can it be right on the line? Well, no, because that would only give you one solution, right? If I just go off of here and bounce off of this and touch that point, that cannot be my answer. If c is equal to 1, if k is equal to 1, which implies that the y coordinate is 1, notice that that's above this 1/2. In that case, I actually will have no solutions for that. And if it's anything above this line, it's not going to give me a solution. All right, so the answer has to be 0. Why? Because if I put another point right here, how many times did I cross this pink line? I crossed it twice, so that's where the two solutions are coming from, okay? Now, we're not sure exactly what those two solutions would be, but we know that there's at least two. Well, this can be kind of confusing, especially the homework, right? So make sure to ask, because there's some very precise definitions you have to use when it comes to this.